Hello everyone, I welcome you all to Startup Academy, India's exclusive coaching for ISS. In this lecture, we'll be covering the topic numerical analysis from statistics paper 1, in which we'll start today a new topic which is dividend differences. Now, what are dividend differences? By the name only, you would know what is it. Dividend differences. Differences means Differences mean that we are subtracting a function from another function, and dividend means from it the word divide. It means that we are dividing. Suppose we have a function. Suppose we have two functions, fa as capital A and fb as capital B. So the dividend difference from of both the function will be f. Suppose I am writing the dividend function of that, it is denoted by delta, or we can simply write it as f a comma b. Then this would be fb, which is the second function, minus fa upon b minus a. Here we are dividing the original terms in the denominator, means we are dividing the difference. First we are calculating the difference, which is this fb minus fa, second term minus the first term, and then dividing this term by the original values, or the values that we take for x. We take these values as x, right? Fx equals to y. So x, the original values, the differences of original value, we are dividing by that, and hence the name dividend differences. Now dividend differences can be calculated for two way. It starts from two functions, and it can be calculated for n number of functions. Okay, suppose this we have done for two functions, so we can write f a comma b as fb minus fa upon b minus a. This we have done. Now if we have to calculate f a b c of three terms, then what will we do? We will write it as f b comma c up minus f c comma b comma a upon the last term, which is c, minus the first term, which is a. C minus a. This is the term we are talking about. And if we have to calculate for mth term, suppose we are calculating f a b c and up till n, then what will be right? F n. So before n, there would be a term known as m. So we will be taking f n, sorry, here it would be f m comma n minus f m comma a upon n minus a. The last term will always be the first term in the difference of the dividend, and the first term will be the last term of this side. This is the formula, or this is the trick. How do we remember the formula? This is how you can remember the formula. The first term will be subtracted from the last term of the function. The first term will be subtracted from last term, c minus a, b minus a. Okay. And in this also you can keep it moving like m n and so on. M n, l m n o, a n m l, and all those things. And here it will be also like that, a b c d up till m. Okay. Here, if I write it clearly, how in expansion form it will be written, then writing it would be equal to f of, we'll start with b, c up till m, n, last term, minus f of, we'll start with a up till a, b, c up till the second last term, m, and we'll divide it by the last term minus first term. So exactly this would look like this. Now dividend differences can be represented by this, or it can be represented by this. Delta with a dash, with the line in between, seems to be a perpendicular line, and we write B, and here we write F, A, comma, B. Or we can also write it as simply FA, or we can write it as delta B F A comma B. This can be written as delta B C, not comma, delta B C F A, and this can be written as delta B C up till M N F A. These are also the derivations or the writing formula for dividend differences. I hope that it is clear how the formula have we got for the dividend differences. Now we will do one or two questions so as to analyze. Before that, we'll do properties of dividend differences, and then we'll do one or two questions. So the next topic is our properties of dividend differences. This is also an important topic in our from our exam point of view, and I hope that you have been doing the previous topics along with the PYQs, and the previous topics are clear with all of you. So the first property of dividend differences would be that dividend differences are, if we put a dividend differences out of, suppose we have many functions, fa plus ha plus ka and so on, then it is, then we can write it as individually delta bfa plus delta bha plus delta bka. It is commutative, we can say that. Okay, this is our first property. Then if we have, the second property says that if we have a constant, suppose we are finding the dividend difference of a constant, suppose it is fc, suppose this is the function fc, and it is multiplied with a constant, and we take dividend difference of this, then what will happen? It is nothing but simply constant will come outside and dividend difference will get inside. Okay. And the third and the most important property, if I am writing this as dividend difference of BC FA, if I take it as square, now we can also represent it as square. If I have written this for first difference, then I will write square for second difference and raised to the power n for nth difference. Okay, this is also an important property. So if we take this, then we can write it as equal to square of BC f of B should be equal to square of BC f of C. This is also one of the important property. And the last property, which is almost useful, nth difference of a n degree polynomial is constant. Suppose in exam they ask you that what is they have been given a question. Suppose we have been given a quadratic equation, x cube plus 5x plus 6 plus 5x square plus 6x plus 12. Suppose this is our quadratic or 3-degree polynomial equation. Now they'll ask which which difference of this equation will be constant. So the highest degree, we'll see highest degree is 3, so the third difference of this polynomial will be constant. They'll be giving you answers such as option A is given, B, C and D. 3, 4, 5, 6, and you have to choose one. So you will see highest degree, which is 3, and your option A would be correct, that the third degree polynomial, the third difference of the third degree polynomial would be constant. Okay, now let us do one question. We have to find, suppose we have been given an function fx, which is x cube minus 2x. Yes. And we have to find the third difference, which is we have to find the difference up till delta raised to the power 3. The third difference of the arguments 2, 4, 9 and 10. Yes, 2, 4, 9 and 10. All these values, we know that it is the value of x. So let us make a table here. Now, how many columns do we have to make? First is for x, second is for fx, then we have to find three differences. So, three columns for the difference. This will be the first difference column, this will be the second difference column, and the last one will be the third difference column. And we have four arguments, which are the values of x. So here we have been given x, here fx we will take, here we will take delta raised to the power 1 of fx, here we will take delta raised to the power 2 of fx, which is second difference. Here we will take the third difference, delta raised to the power 3 of fx. Okay, so our arguments are 2, 4, 9 and 10. These are our arguments. If we put 2 in this fx equation, 2 raised to the power 3 is 8. 8 minus 4 will be 4 only. So we will write 4 here. 4 raised to the power 3 is 64, minus 8 will be 56. We will write 56 here. 9 raised to the power 3 is 273. 273 minus 18 will be 711. 10 raised to the power 3 is 1000, minus 20 will be 980. You can recheck the values if you have any doubt. Okay. Now the first difference, because we are calculating dividend difference, most of you will get confused here for Newton-Gregory's interpolation formula and dividend difference. We have to divide also in this. That's why it is the name dividend. First of all, calculating the first difference will be 56 FB, which is second difference, minus first difference FA upon B minus A, which is 4 minus 2. So this will be 52 upon 2, which is 26. I hope that it is clear that how are we calculating them. Okay. Now this will be 711 FC minus FB. If it is A, B, C and D. So FC minus FB, which is 56, upon C minus B, which is 9 minus 4. This will be equal to our 131. I'm directly writing the answer, you can check them. Then this will be FD, which is 980 minus 711 upon D minus C, which is 10 minus 9, nothing equal to 1. Just simply write the difference, which is 269. Okay. We are doing slowly so that you understand the concept. How are we doing this? Then again, here we have taken in between the value of A and B, in between the value of B and C, and in between the value of C and D. Just remember that we have to take like this. Now we'll subtract. We'll take them in between of these two. 131 minus 26. Now what will be the differences? Because it is of C and it is of A. So I told you that we have to subtract the smallest from the highest. So highest is C and smallest is A. So C minus A will be 9 minus 2. So our answer will be equal to 15. And here we will be doing 269 minus 131 upon. Now these two are between B, C and D, among B, C and D. So we'll subtract B from D because B is the smallest and D is the highest. So 10 minus 4, and we'll get our answer as 23. Okay. Now the last and the third difference, which is 23 minus 15 upon. Now these are among B, C and A, B, C and D, all of them. Highest is D and smallest is A. So D has 10 and smallest is 2. So this will be 8 upon 8, which is nothing but equal to 1. So we can write the answer as the third difference of this equation is nothing but equal to 1. And these kind of question has been asked in your statistics paper 1. They are not lengthy because we are doing in detail and I am making you understand the concept. They seem to be lengthy, but with practice it is a work of just 5 seconds, 5 or 10 50 seconds or a minute, maximum a minute, not more than that. So as and when you practice, you will get used to solving these kind of questions in a higher speed. That's the case. Now let us take one more question. The example says that we have to find delta of x square y. Okay, delta of x square y. We have been given only one variable, which is y. So that means we have to subtract f. We know that delta of b of f a is equal to f b minus f a upon b minus a, right? So here it is just replacing the values. Delta of delta y f x will be equal to fy minus fx upon y minus x. So taking the common fy, if it is if fx is equals to x square, then fy will be equal to y square. So putting the values, y square fx will be equal to x square upon y minus x. So if we solve this, y minus x into y plus x upon y minus x. These two will get cancelled and we'll be left with y plus x. This is the answer of our delta y of x square. This was also for just to make you understand, I'm writing the whole concept. If I know the concept, I will just write this. I will just write this, and from seeing this, I will say that my answer is this. So if in the question they have given you options like A, B, C, and D, they have given you y plus x, y minus x minus y, none. So just seeing this, I can solve this. If I know the formula, I will directly write this, and just seeing this, I will write that my option is correct, x plus y. So this is how you solve the questions. As and when we'll complete the numerical analysis lectures, all of them we'll cover. Then we'll take a few questions from the PYQs and we'll solve them on the board within a small limit of time, and I'll tell you what are the tricks to solve them in a limited amount of time. So this was all for today. I hope that you understand what are we doing in the class, and if you don't, then you can ask in the comment section or on our WhatsApp channel. Only relevant doubts will be answered. And about our Lakshya batch 2027, we have launched a new batch which will be starting from July 15th this year only, 2026. And all those who are serious for their ISS preparation and are preparing for 2027 can join and enroll in the batch. Details can be asked on the number given in description, and you can see the lecture video that we provided on that Lakshya Batch 2027. All the best. Thank you.
Startup Academy presents Lakshya 2027, an exclusive batch designed only for serious ISS aspirants.